Hi students, coming to the next topic in the subject operating system was Semaphore's implementation. So in the previous video I just explained about what exactly the Semaphore is. So let me explain once again. A Semaphore is nothing but it is a variable. It has two variables. Semaphore is having two variables. So that is like wait and signal. So these are the two variables which are used to solve the critical section problems. It is used to solve critical section problems and also to achieve process synchronization. So that is the main thing. To achieve the process synchronization, we are using the Semaphore's variables in multi-processing environment. Actually, the critical section problem may arises only when you're dealing with a multi-processing environment. So if your system is a single processing, only one processor is entering at a time, then there is no problem with the critical section. Means one process will execute, after that another process like that. So there is no problem of thinking about critical section. So whenever there is a multiple processor is accessing the same thing at a time, then conflict may occur. So to achieve that process synchronization and to solve the critical section problems, we are using Semaphore's variables. So the main thing of using the Semaphore's variable is we have to maintain the process in a synchronized way, and we have to make that system is not in busy state. Okay, the main thing is it is a synchronization tool that does not require busy waiting. So for that reason we are using the Semaphore's variables. So whenever you are given a Semaphore, means you have to write that Semaphore is nothing but it is a synchronization tool. There we are used two variables, wait and signal. These variables are used to solve the critical section problems as well as to achieve process synchronization in multi-processing environment. So wherever your case is a multi-processing environment, there to achieve the process synchronization. So the main to achieve this process synchronization, we are using this Semaphore's variables. Now let us see what is this, how we are implementing this Semaphores. So there must be guaranteed. So whenever you are using the Semaphore's variables, means there must be guarantee that no two processes can execute wait and signals on the same Semaphores at the same time. So that condition you have to follow. While you are implementing, you have to follow that. There must be guarantee that no two processes can execute wait and signal. So these are the two Semaphore's values. So these two wait and signals on the same Semaphores at same time. So to achieve the process synchronizations, you have to follow this condition. There must be a guarantee that no two processes can execute wait and signal on the same process on same Semaphores at same time. And thus implementation becomes the critical section problems. So where the wait and signal codes are placed in critical section. So this is how you have to implement the Semaphores. So while you are implementing the Semaphores, you may get the problem like deadlock and starvation also. Okay, let me explain about what is this deadlock and starvation. So here I am just giving a brief explanation about the deadlock. Actually the deadlock is somewhat a complicated big topic, so that I'll explain later. So now I'll just give the brief discussion explanation about deadlock. A deadlock is nothing but it is whenever you are taking the two or more process or waiting indefinitely for an event that can be caused by one of the waiting process. I think you didn't understand. Let me explain that. So deadlock may occur when two or more process, if you are taking the two or more process, this two or more process trying to get the same multiple resources at a time, at same time, let me write at same time, then the deadlock may occur. The deadlock may occur when two or more processes try to get the same multiple resources at same time, then you call it as the deadlock may occur. So what is that? Let me take some live example. Suppose here a road was there. This is a very thin road. So on this, one truck was coming this side, it stopped here, and another truck was coming this side and it stops here. So this truck wants to go this side and this truck wants to go to this side, but at this road only one truck can be passed at a time only, means one there is a space only for one truck. So what they have to be do, this person can move back, then another person will forward. Otherwise this person can move back and this person may cross. But here these two people may get ego, means he says that I won't go back and he says that he won't go back. So they both were in deadlock state. They are blocked until one of the process has to be sacrificed, then only the other process may continue. But here no one was ready to sacrifice. So this condition is you call is a deadlock. Or let me take one more example. So here is your this is a process P1 and the P2. Suppose this is yours, you and your friend. So both are talking in a phone. Okay, so you are dialing your friend's number, and at the same time your friend is also dialing your number. Okay, dialing at same time. So the deadlock means you have to think about the main thing is same time you have to be remember. So this your friend and you both are dialing, and you're calling to your friend, and your friend is calling to you. So you will get busy, completely busy. That you call it as indefinitely busy. Okay, indefinitely busy. So whenever one of you and your friend, any one of you, if you put on your phone, or if you are not supposed to dial, then you may get the call, but you're continuously dialing and your friend is continuously trying to your number. Your friend is continuously trying to your number and you is continuously trying to your friend number. So whenever you both any one of you has to compromise, then only you may get the call. But here you're continuously trying. So this you call it as a deadlock. So this deadlock may occur in the by using the Semaphore's values also. Means like, let me take, suppose a P1 is a process and the P2 is a process. So here this process is taken the S1 semaphores, and S1 is taken and it is waiting for S2 semaphores. Okay, the P1 has taken S1 semaphore's value, okay, and waiting for S2. And here P2 is, S2 is taken and it is waiting for S1. So this condition is a deadlock, because until this P1 releases, this P2 won't take. Okay, so whenever it is releases, the P1 releases the S1, then the P2 will take that S1. So whenever this P2 S2 is releases, then only this P1 will be taken. Means here these two semaphores will be blocked, and here this is also blocked. So this is what I am explaining, that this is semaphores. A deadlock may occur. Means if you didn't use the semaphore's values, it may deadlock may occur. And next is a starvation. So starvation means indefinite blocking. That is, a process may never be removed from Semaphore's queue in which it is suspended. That you call it as a starvation. Means if already in the Semaphore's queue some variable is or there, some process is there, if that process is never be removed, even though it is suspended, the Semaphore is suspended that process, even though it is suspended, that process is never be removed from Semaphores. So that you call it as a starvation. And one more problem that will be raised here is the priority inversion. Priority inversion. So what is this priority inversion? Priority inversion means if you take the schedule, this is nothing but a scheduling problem. And scheduling problem, when low priority process holds a lock needed by higher priority process. So the higher priority process will need some lock, but that process has hold by the low priority. Okay, so this can be solved via priority inheritance protocol. So these are the three techniques that may arise while you are dealing with the Semaphore's implementation. So whenever you are doing the Semaphore's implementation, you have to think about the deadlock, starvation and the priority inversion while you are dealing with the some critical sectional problems. And to make the process synchronizations when you're in a multi-process environment, if you want to make the process in a synchronized manner, and to solve the critical section problems, you need to take care about this deadlock, starvation and priority inversion while you are implementing the Semaphores. Thank you.